So yeah, again, good morning, everyone. I'm Prasanna Deshmukh. I don't work directly on kind of observational astrophysics also. I'm an instrumentation engineer, which means I do build telescopes. So at IIA, I'm working for a telescope called as 30-meter telescope, which will be world's biggest telescope. And we are doing it for last 10 years. It will take another 10 years or so. But that telescope will be so huge that we'll be able to see uh, things in much more detail within our solar system or even outside. Today, we are celebrating International Asteroid Day. Actually, it is supposed to be 30th of June. We have arranged it for today. And yeah, so let's start. And as I said, like I was asking in the beginning, how many of you have seen some astronomical bodies which are coming from outer space? Of course, Earth is itself is an unique planet, which is an astronomical body. So if you are on the Earth, you are already have touched and felt how an astronomical body feels like. But since we are on a frame of reference, which doesn't make us realize that Earth is so huge and it is floating in the space, uh, it will be interesting to see how other objects looks like when we see them through the telescope. So first of all, what is an asteroid or what are the asteroids? So basically, these are small rocky objects made up of dust, then rocks, then metal, and sometimes some water content as well. So these are the bodies which are coming from, which are outside our Earth atmosphere or Earth's orbit, and they come from something called as asteroid belt. So this is an asteroid belt. The reason why these asteroids or these bodies are there, and these are basically rocky objects from the size of few meters to few kilometers. Okay, and most of them are situated here, and this is because this is a place where gravity is stable, or rather, gravity is such that it allows these small objects to float around in that empty space. Okay, now where they have came from? So we had to go back few billion years and see how Earth was formed or how our solar system was formed. So there was a big cloud, and there were small clumps of clouds within that big cloud. Now these small clumps of clouds, because of the force of attraction, these gas clouds started coming closer to each other. Okay, and hydrogen got fused into helium and so on, and it started forming heavier metals. Now once the metals are becoming heavier and heavier, they started getting basically accumulated at the center of this small cloud of gas, and whatever was left around got also, that also got kind of combined into small clumps. That's what formed these planets. Okay, so sun is a big gas cloud along with heavy metals. Along with that, these are the remnants of that smaller cloud which got collapsed and formed a star, and this is a remnant. From this remnant, again, there were several planets which were formed, but this particular zone here, while these planets were forming, they were getting influenced by sun and other bigger planets which were getting formed. And there are other big planets which are outside as well. So the planets which are formed here, the gaseous elements on these planets got ripped off because of the sun, whereas the outer planets, those are all gas giants. Basically, gas around those planets remained intact because the forces acting on these planets are relatively smaller compared to sun, compared to the inner planets. And the in-between zone is kind of maintained intact. So these asteroids are from the beginning of our solar system. Okay, so they carry a lot of signatures of how things were at the time when Earth got formed. So we can get chemical compositions of the gas clouds as well as the dust and debris at that time when the sun and Earth were getting formed. Okay, so these are typically in the belt of Mars and Jupiter. So you see, this is a Jupiter orbit, and the Mars orbit is here, and there is a belt. We call it as asteroid belt. So most of the asteroids come from this space. Of course, there are exceptions, but these are the asteroids. Now, whenever people talk about, oh, asteroid is a big worry for us, we are not talking about these asteroids. There are other asteroids as well, which once in a while change their path and kind of cross the Earth's orbit. So Earth orbit, if you try to locate, it is here. And if there is an asteroid, for example, this is an asteroid which is crossing the Earth's orbit or coming closer to the Earth's orbit. These are the objects which we are mostly worried about. These are called as near Earth objects, okay, NEOs. So as I already indicated, if you zoom out a little bit, this is the Sun, Mercury, Venus, Earth, Mars, and then between Mars and Jupiter, this is a place where there is an asteroid belt. Okay, so if you have heard about comets, there are similar kind of belts for comet as well, something called as Kuiper belt, okay, from where comets come. So comets are slightly from the outer orbits. So when we're talking about their sizes, these are the sizes of asteroid. So the biggest one is around 1,000 kilometers. Okay. Then next one is Vesta. So if you want to remember some of the names, so Ceres is the biggest asteroid. Okay. Now it is also called as minor planet, and Vesta is also the second biggest, whereas it is brightest as well. So because its surface is reflective, when we see through a smaller telescope, we can see that it is much brighter than Ceres. Okay, and then of course there are other planets, other asteroids. The Apollo asteroids are basically the asteroids which are coming close to the Earth's orbit or crossing the Earth's orbit. So that category of asteroids is called as Apollo asteroids. Okay. And what are they made up of? As I already indicated, they are made up of rocks, metals, and mix of both, sometimes water content as well. So based on their composition, we categorize them into three types. One is C type, S type, and M type. So C type is basically most of the asteroids are of C type, and they are having chemical composition of carbon and minerals, whereas S type are mostly made up of iron and silica, whereas M type are purely iron. So what I'm going to show you today, I have a small piece of, you can call it as asteroid, or there I will further indicate you there are derivatives of the asteroid or comets. So this is also called as meteoroid, and it is purely an iron based meteorite. Yeah, so this is how it looks. What you will see today in these boxes is shown over here. So iron meteorite. Okay. So why they have different composition is because, as I told in the beginning, hydrogen fuses together and forms helium, and then helium fuses and then forms higher and higher atoms or higher and higher elements. And the most stable element in the star formation is the iron. So beyond that, it is very hard to form the higher order elements. Okay, so iron is relatively stable, and it is the core of the planets or stars, or like big planets rather. Mostly those planets which are having core within it. So even you know that Earth's core is made up of pure iron, right? Molten iron. So this is what you will be able to see. And of course, there are combinations of different meteoroids or asteroids. So as I indicated in the beginning, these are the famous asteroids. Ceres is around 1,000 kilometer Vesta. You can see it is relatively smaller, but it is much brighter because this is made up of a lot of dusty surface. This is a rocky, and hence it can reflect more amount of light. So if at all somebody says that I have seen an asteroid through a smaller telescope, they might be talking about this asteroid, because most of the other asteroids are smaller in size. You can't see them through the telescope. This big asteroid is big, but it is far away as well. So hence, this is one of the key or main candidate of asteroids which you can see through the telescope. Now, when you want to see them, they have to be at a particular angle from the sun. So if I just try to draw it here, suppose this is sun, and here is the Earth. We are looking in this direction when sun is there, and then suppose asteroids are going in this orbit. So whatever asteroid-based objects I told you before, you can't see them when they are here because they are far away from Sun Earth system. Okay, and the light reflected from them is relatively less. What happens is if they are at roughly 15 to 20 degree away from the sun, that is when they get illuminated by sun's rays, and this angle is such that it reflects majority of the light towards Earth. Okay. So this is the zone in which you should be observing the asteroid. So at any given time, we are able to see this zone. Okay. So if any asteroid is coming closer towards us, we will be able to detect only in this zone. Whereas if there is an asteroid over here and it is trying to come close, we can't detect them easily because the light reflected from them is not at particular angle, which which is similar to, you might have seen an aeroplane in the evenings, right? When it is evening, sun rays are kind of reddish, and at that time you can see a aeroplane passing with its fumes getting illuminated by sun rays, right? So because that angular alignment helps you to detect them easily because the light reflected from them is quite more compared to when they're at other positions. So at any given time, if you're visually observing, visually in the sense by using a telescope or so, by using light, then you can see in this zone only. But these zones are kind of blank. So hence it is bit difficult to predict asteroid unless they come very close to us. Okay, and that's why every now and then you can see that some asteroid falling at different places on the Earth, right? Of course, they are not very big. So if at all you want to worry about certain asteroids, we have to worry about asteroids which are larger than 10 kilometer. If a 10-kilometer asteroid hits a particular place, it can have a very bad implications. Okay, it can kind of destroy complete cities as well as it can impact the Earth's stability. Okay, so but the probability of that is very less. Now, what is the probability of a big asteroid? When I say big, anything beyond 10 kilometer and above. Okay, the probability of that is 1 million years may one. Okay, so once in a 1 million year, it can come and hit the Earth. Okay, so if you see our lifetime is the next 100 years or so, so we don't expect that this will happen. Okay, because we know already all the million year kind of or all the asteroids which are larger than 10 kilometer, which are around us, we know very precisely that for next 100 or 150 years, they are not going to come any close to Earth. Okay, and how can we say that is because when we are observing these asteroids, we are continuously monitoring some key asteroids which are of larger size. So there is suppose an asteroid over here, there is asteroid over here, here. So we keep them observing either through an optical telescope or radio telescopes. Okay, and keep mapping their orbits. So how it is going around the sun at different stable orbits. Okay, so like this we keep tracking them. Okay, now what happens when they are going around? Earth is also going in this orbit, right, around the sun. At the same time, Jupiter is moving its position because Jupiter is a heavy planet. So it is also having gravitational impact on other astronomical bodies. So even if we consider all these effects, effect of Earth moving, effect of moon around it, effect of sun, effect of all this entire system being dynamic, we cannot predict beyond 100 or 150 years in future where these bodies will be. So roughly we know that where these bodies will be, and in next 100 or 150 years, we know for sure that none of this asteroid bigger than 10 kilometer is going to come any close to us. Okay, so in our lifetime, we don't have any danger of asteroid coming close to us. But if at all we detect something new or even a smaller size, so if it is a 1 kilometer or a few 100 meter asteroid, it can destroy a complete city as well. Instead of complete Earth, it can destroy a city or it can destroy, kind of create tsunamis and all. So those we have to worry at the same time. Hence, there are different missions which were thought about and they are being executed as well, so as to see whether we can deflect the asteroid's orbit or whether we can destroy them completely or not. So yeah. So when I was in school, like you, in 2006 or so, yeah, 2006 or 9, I guess, I forgot the exact year, there was a debate in the society. Like now, what is the debate going on about astronomy? Anyone knows? Yeah. Pluto is a planet. Yeah, that was debate when I was in school. Now, anything you know about present astronomy scene? Yeah. Like largest black holes. Yeah. Yeah, people are discovering larger and larger black holes. People are discovering older and older stars. There are any water reserves on Mars. Water reserves on the Mars, yeah. Yeah, planets. observing the exoplanets and seeing if there is a life around it. Yeah, so all these major problems, I think these are the problems which are going on for centuries, and it will take maybe another 20, 30 years for figuring out. Yeah. White House. So I have not never heard of them, but yeah, these are the new things. Yeah. I mean, since I have not heard it, it doesn't mean that it is not true. It might be. People are observing it. Yeah. All right. So all this kind of news you might be reading in the newspapers. So during my school days, this was the kind of debate. Why? Because astronomers were discovering newer and newer planets. Okay. So, or newer and newer asteroids rather. At that time, we were having 9 planets in our solar system, and every year there is a conference called as International Astronomical Union conference, where people come and say that, okay, look, we have discovered these objects. What should we do with them? Should we call them planets? Should we call them asteroids or something else? So people came with a big list of minor bodies, like a smaller objects, which are considerably large, but they are not fitting all the definitions of typical planet. So what they discussed is, apart from these objects, even Pluto is also falling in this category. So instead of adding so many planets in our own solar system, like just giving them name as a planet, let's call them as a minor planet. So hence, all these larger bodies were called as a dwarf planet or minor planets. Okay, and then we removed one planet from our solar system, which was Pluto. Okay, so Pluto, you can see that Eris is slightly larger than Pluto, and all these other objects are also equally large, right? But instead of calling them as a planet, so some of the key differences between planet and a dwarf planet, who can tell? Yeah.
Mostly a planet must be almost spherical in shape, and
Okay.
it must clear its orbit, and it must not cross other planets' orbit.
Oh, perfect definition. Yeah, I think he answered. You have any other point?
Stable gravitation and force.
Yeah. So what happens is, when you are around sun, it's like mostly the gravity of sun which is influencing you. Yeah, but I mean, you might have studied in the physics classes that every body has its gravitational force base, and this force kind of strength depends on its mass, right? So sun is very massive, so it will have very high gravitational force, but every object in the universe will have a gravitational force around it. Yeah. So yeah, so all the definitions, these particular smaller planets were not able to meet. Hence, we call it as a dwarf planet, right? So we have, that's why 8 planets in our solar system. So if we think about anything apart from planets, what are the different things we should talk about? One is comet. Most of you might have seen comet. Any name of comet which you have seen? You have seen Halley's comet?
Yeah.
I heard about.
Okay, I was also not born at that time. Yeah, yeah. 1986. Yeah, I was 1987. Yeah. So next time it will come in around 1965 or so. You'll be there. So 2061. Yeah, 2060s. Yeah. Any other comet we have seen recently?
2020.
Yeah, there was a comet called Lovejoy. You might have seen during the lockdown period. Yeah, comet Lovejoy, and then there was recently also there was one planet, comet Neowise was there. Correct. So yeah, all these comets were visible from Bangalore as well. I have seen them. Yeah. So there are comets. These comets are basically dust, rocks, and ice, right? So these are coming from outer part of the solar system, typically Kuiper belt. Okay. Then there is an asteroid, what we are talking today. Asteroids are again dust, metals, okay, and sometimes water, and they are between Earth, they are between Mars and Jupiter's orbit. Okay, these are the remnant of solar system formation, and these are basically rocky objects. Now comes the interesting part. These comets and asteroids are relatively larger. They have a kind of relatively fixed orbits, and they are from the remnants. Now, whatever is remnant of these two becomes a meteoroid. Okay, so what are the meteoroids? These are the small particles. You can see small particles left behind. When an asteroid is little loose, it is not made up of a single rock. It is made up of some small boulders and all. when they get separated, and because of their smaller size, nearby massive object will pull them towards it, right? So meteoroids are basically small kind of remnants of asteroids and comets. So when the comet is basically a big ice ball coming from outer part of the solar system. And when it starts coming close to the sun, starts melting because of the sun's heat, ice starts melting, and then it creates this kind of a big coma, which is a big gas cloud and tail, right? So this is the backside is the tail. And this tail is nothing but dust particles or water molecules or ice particles which are getting illuminated by the sun's rays falling on it. So what happens sometimes a comet comes from far away from our solar system and goes around the sun and goes away, right? So when a comet comes, this is at this place it is a one single body. At this place it starts forming tail. When it is close to sun, it is having a massive tail. Goes around, the shell will turn back, right? Like this. So now you see this place, it is crossing the Earth's orbit, right? Of course, the probability of a comet hitting Earth is almost nil at this point of time. But when a comet has passed, it has left behind some dust particles or ice particles and so on and so forth. And when Earth passes through this region, this part of the sky, then these remnants will get pulled towards Earth because Earth is having a very massive gravity compared to these small objects, right? And they will start coming towards Earth, and hence you see a yearly meteoroid phenomenon, right? Meteor shower we call. So anyone has seen meteor shower before? Yeah, which one? Lyrids, yeah. Anyone else? Lyrids one. Yeah, the one of the best meteor shower is in December month, 15th December. That is called a Geminite meteor shower. Okay. So during this time, there is a comet which pass through the Earth's orbit, and then whenever Earth passes this particular patch of the sky on 15th December plus minus 1 day, then you see that shower of meteorites. And now typically they come from a particular angle, right? That's why whenever Lyrid means it is from coming from the Lyrid constellation. Gemini means it is coming from Gemini constellations. You know where to look at, right? Because that is the part of sky from where you will see them coming towards Earth. Okay. Now, yeah, so meteoroids are basically remnant of comet and asteroid. Now, when a meteoroid is in the outer space, it is called as meteoroid. Okay. As soon as it passes closest to any object, typically Earth, Earth will start pulling it towards us. And then what we see is a meteor. So there is a meteoroid, and then there is a meteor. Meteor is basically the one meteoroid which is coming in the Earth's atmosphere. Okay. That is called as meteor. And you can see this kind of small, fast moving object with a small tail around it, right? If you have seen the meteor shower. If not, then even from Bangalore sky, it is a little hard. But if you go outside the Bangalore, you'll be able to see meteor shower. If you go to remote places where we have our observatories, like in Ladakh or in near Vellore or yeah, where else? In Kodaikanal. There you will be able to see these meteors almost every single night because there are millions of dust particles or small rocks which comes towards Earth every single day, right? So this will be a meteor. Sometimes these meteors are relatively larger. So when they're passing through Earth's atmosphere, they will glow very bright as well as they get broken into small pieces. And you can see them like a fireball. So that's what those called as fireballs. And meteoroid is the one which is this rock coming in the Earth's atmosphere, trying to get burned, and but still survives through the Earth's atmosphere, and it will come and fall on the Earth. Now there are people who are interested in collecting them, and they go and collect it, and that's what get packed into this kind of boxes, right? So this is a actual meteoroid coming from this process. Okay, so there are these are very small comparatively, but relatively sizable meteoroids will be of the order of few hundred per year. So very few fall on Earth. Now you know that 70% of the Earth's surface is covered with water. So most of them will fall on the water, fall in the water, right? Or on the ice caps in Antarctica and Arctic. So it's very hard to find relatively larger size meteorites. Okay. I already told about near Earth asteroids, the asteroids which come in the in the vicinity of Earth's atmosphere or Earth's orbit. And there is a bunch of asteroids, which are also called as Apollos. Basically, these are the ones which will cross the Earth's orbit. And as I said, there is a safe, I mean, an asteroid can pass nearby Earth. There was a asteroid a couple of years back, which passed closer to Earth, and it was in between Earth and Moon's orbit. So it passed in between that. Okay. Fortunately, it was relatively smaller and it just passed without causing any harm. But it was detected just one day before. Okay. So because they are smaller, we can't detect them in advance through optical means as well as through radars because they're so small and the amount of light or radio waves they can reflect is very small. So because their surface is not reflective. So hence, small size meteoroids are something to worry, and we can't detect them. And even if we detect, we'll be having only a day or two warning. Yeah, but they can't destroy entire Earth. So yeah. So this is how this is just a pictorial depiction. So asteroids can come and impact Earth. Now, most of the time they get burnt into the Earth's atmosphere. That's what we are seeing. And today's day we are celebrating, just for your information, is 30th June. Means it was for 30th June. And why we celebrate is because on that day it marks the event of Tunguska asteroid impact. Now this impact didn't happen physically. When this particular asteroid of the size of around 50 to 60 meter, we are talking about a relatively small asteroid. Okay, it came and got kind of exploded at a distance of 5 to 10 kilometer in the Earth's atmosphere. It kind of wiped off around 2,000 square kilometer of area, and only, of course, casualty was relatively less because at that time this is 1908, so this particular place was not so much populated. So 3 people died, but if similar event happened in today's era, it will be much kind of dangerous in that sense. But yeah, so it was 12 megatons of kind of explosion, which is much larger than even an atomic bomb. In recent time, in our timelines, 2013, this particular event happened. This was one of the biggest event. You can see this is in the Russia. Okay, South Ross in 15th December, 15th February 2013. Now this event also, it got burst at 30 kilometer above the Earth's atmosphere. Its size was 18 meter. Okay, but it was dangerous. I think some 5,000 people got hurt. Okay, not no one died, but they got hurt because they could see this particular flame coming through their windows. So everyone was watching through their windows, mostly made up of glass. And when it kind of blasts, it creates a shock wave, which you can't see, but you can feel it. And because of the shock wave, all this glass were shattered, and then most of them got hurt because of this. Okay. Of course, it didn't reach the ground as a full piece. Yes, this kind of event happens. This is one of the recent and biggest event. So these are the kind of, this is a map where you can see where all asteroids have made impact and what is their strength. In India, relatively less, but there is one in Maharashtra. It is called as Lunar, uh, and one of the biggest one is this one, Beringer crater. Now, this particular person named Beringer, around I think 100 years back, he was exploring. He was a kind of a miner, and he was exploring this area, and he found that, oh, there is a crater. He claimed that this is made up of some asteroid hitting. Nobody believed him. So what he did is he took rides for uh, basically mining this particular crater, because what he thought is, oh, some big iron ball has fallen inside this. So if he starts digging down, he'll find a free source of iron, right? You don't have to process it more. It is a pure iron. So he thought of like just drilling it. So if you go now there, you can see a lot of drills in vertical direction as well as horizontal direction. Because when he was searching in the vertical direction, few hundred meters, he found that, oh, there is no iron as such in a single piece of iron. Then he started searching in the other directions. He couldn't find, because at that time he was not able to anticipate the physics or science behind how this particular thing forms, right? Whereas what happens is when an asteroid hits, at the time of impact, it basically vaporizes that full iron ball. Okay, it creates a kind of a bomb kind of scenario, where as soon as it hits, it vaporizes the entire material within it, and that vapor, which has a lot of heat and kind of outward force, that creates the crater. So the original material can't survive in its single piece, and it gets shattered across this region. So hence, if you go to any craters, you will be able to see magnetic materials like the rocks which are having magnetic properties, which are formed during that time. One more interesting thing which you can see at the crater site is glass beads, okay, small pieces of glass. Now, this glass is not naturally formed; it is formed due to impact. So, of course, our Earth's surface will have silica in it, right? And glass is made up of silica. So, what happens whenever there is an impact, because that huge impact force as well as temperature, the silica gets converted into glass, and you have one piece of that as well. So this is called as tektites. Okay, so this is made up of asteroid impact on Earth, and you can see, yeah, this is almost 800,000 years old impact. Okay, from Vietnam. Right, so it creates this kind of craters, and this kind of rocks also you'll be able to find in these craters. So Lunar is something which is closest to us in India. It is 52,000 year old, and it is around 1.2 kilometer wider and 150 kilometer deep. What is interesting about this is, if you go and those who are biologists who study this kind of craters, they have found that it has a lot of extremophile bacteria. So now what are these? Are basically, typically we have bacteria on Earth which are formed naturally. So they can't survive very extreme temperatures and extreme pressures. Whereas these extremophiles are able to survive for longer or for higher temperatures, elevated temperatures and pressure. So these are basically, people believe that might have came along with that asteroid which impacted this zone. Okay. And there is another one, this particular crater, Dhala crater in Madhya Pradesh. It is of 3 kilometer wide and 2.3 billion year olds. So it's quite older than this. So yeah, we have seen that meteoroid, which when it is in space, it is either part of an asteroid or comet. When it is in Earth's atmosphere, meteor, and when it falls on the ground, it is meteorite. There are different types. Again, I think I have indicated already. The one which we'll see today is this. Now, since technology has evolved so much, what we can do about it? So if we know that there are some asteroids which have potential to come towards us, and if we can predict their path, and if we know for sure that they are in the danger zone, we can go and do something about it. So there are different missions so far. Some of the missions are for diverting the path of the asteroid. Some of the missions were planned for destroying the meteoroid or asteroid completely. So the problem with, as I shown you this orbits, suppose an asteroid is coming in this orbit, and if we kind of blast it with some nuclear weapon or so, it will get shattered into pieces, and we don't know, because that process is very chaotic. We don't know when it breaks into pieces, how many pieces it will break, and where those remnant pieces will come and fall. We don't know. So in that context, we don't want to kind of completely destroy asteroids. What we can do is we can put some rockets and try to divert their path. Okay, so when it is coming like this, we can slightly upgrade the path when it is in the outer solar system, and then try to do this. So because of this, it will never cross the Earth's orbit. Okay, so there was a one asteroid whose orbit was, when it was predicted. This is during the time when Indonesia tsunami was seen, right? So that created a lot of news, and nobody noticed that, oh, there was a news in astronomy journals about asteroid being detected, which is having very high potential that it will come and hit the Earth's orbit. Now, it was a preliminary calculation. When people calculated it over a period of time, they found that it is now slightly safe. Okay? It will not hit at the predicted date, but it will hit after 7 years after that, right? So what happens is, asteroid will come. We detected it here. Now we know that it is going to come and go close to the Earth's orbit. Okay, like this. This is the Earth's orbit. We know, and this is the danger zone. When people did calculation, they found that, oh, that is not the case. It is going to go slightly above. Now, but what happens because it has come very close to the sun, it will turn back and come and next time it will hit. Okay, so now there is a study going on this particular asteroid. I forgot the name, but people are studying such kind of asteroids and predict when they will come and hit the Earth. So there are different missions which are notable missions. There are other missions as well. One is Osiris X. This was during just after the lockdown, 2020, 2023, wherein this particular uh, mission landed on the Bennu asteroid. It collected some samples and got it back. So this is the first sample return from Bennu. Okay, so it was kind of landed in one of the desert using parachutes. There was another mission called Hayabusa from Japan. This also landed on, or rather, it collected material from this Rygo uh, asteroid, and there was a DART mission. So these are some of the notable missions. The first two are sample return missions, wherein from here, we do something called as spectroscopy. What is mean by spectroscopy is when, suppose, for example, when you get hurt on your hand, like if you get into an accident, you go to doctor. Now, doctor is not able to see any visual sign that there is some problem with your hand. But when he does an X-ray, he can see inside and see that, oh, there is a bone which is fractured. Similarly, what we do is when whatever light is coming from the outer solar system objects, right, we split into its colors and try to see which are the colors corresponding to different elements or gases within the atmosphere of that object. So that way, via spectroscopy, we can detect what is there on the bodies, astronomical bodies. But the light coming from these objects is so less that we can hardly see them as a small blob of, I think I have shown in the next images. Yeah, you can see this is a very high resolution because this image is taken by the satellite when it was very close to the asteroid. Whereas when you are far away, you can see a just spot of light passing in the atmosphere. So in that context, we can't simply rely on the spectroscopic data. So for that, we have to go and collect the material, bring it back, safely open it, and inspect it. So when this kind of missions were done, what they found is, again, this is an image from Osiris X before the sample return. Okay, this is taken when with a very close approach. What was observed was also that it is not made up of single piece. There are two lobes to it, and these two lobes are just lightly touching each other. They're not like a single piece. Okay, this is another mission, which is Hayabusa, and this is a DART. So I think I had given here. Yeah. So in this previous mission, they were able to see. Yeah, this is the one of the finding. They were able to find 14 types of amino acids and 5 nucleobases. And in this particular case, they were able to see again amino acids and then vitamin B3, liquid water, and so on. So this is possible only because we can bring the material back to Earth's atmosphere, Earth, and inspect them. While doing that, we have to ensure that we are not going to contaminate these samples because when you're opening it, your hands will be full of greases and dust and other stuff. So we have to ensure that it is opened in such a sterile environment where external contamination doesn't kind of cause any problem, right? This was very interesting mission again. Again, I was in school when this mission was conceptualized, and that time you might have seen the different outreach programs, right? You had to participate in competitions and stuff like that. So during our time, there was some kind of competition, and if you can kind of score certain marks, your name will be etched on some metallic disc, and it will be put inside this mission, and it will go and hit an asteroid. Okay, so that was the thing. So I participated in that, and then this particular mission carried my name along with thousands of others, and it went and hit the uh, this particular meteor asteroid basically. So these are the observations taken by James Webb Space Telescope and Hubble at the time of impact. And as you can see here, this is just stars, but what you see in the background are just stars. And when you see this flare, it is the time when it has impacted. It has created a big impact and thrown out so much of material, right? So what happens is when you are carrying, suppose, 1 ton of material, out of which 700 kg is removed, right? So whatever remaining material is there, that will have different force of gravity compared to before, right? So you are removing the material, and the orbit of the asteroid around the sun will depend on its mass, right? So hence, when you reduce some mass, it will change its direction. As also that impact will cause some change in the, because you might have studied every action has a reaction, right? So if you apply some force due to a rocket hitting, it will have reaction force which will cause it to go slightly away from its original orbit. So that was helpful. And what people found that this particular asteroid was able to be deflected by 32 arc minutes. So every degree is, if you divide into 60 halves, each one of it is called as minute. Okay, arc minute. Okay, so our plan was to just deviate by 3673 seconds. So what it means is, suppose this is 360 degrees, right? If you divide 360 into this, like full circle, into 360 halves, that will become 1 degree. 1 degree is equal to 60 arc minute, and 1 minute is equal to 60 arc second. Okay, so 60th part of that. Right. So plan was to do it by say 73 seconds, which means it is roughly 1 minute we wanted to do. And what was done is around half a degree. So that is very good. So such kind of missions will be used for major asteroids, which are kind of expected to come and hit the Earth's atmosphere. Yeah, this is another movie from the same mission where it was closely approaching, and these missions are having double benefit. One, we can see remotely and see how their path is getting deviated. At the same time, we get such a kind of closer look, because which we have never got previously. You can start seeing. So this particular asteroid is also having a moon of it. So this is the main asteroid, and this is the moon. As it passed by the moon, comes and hits. Yeah. So you get to see that it's a rocky and what is the reflectance of the surface and so on and so forth. Yeah. There was one interesting asteroid which looked like this. It was a little elongated asteroid. In 2017, it was discovered, and it was found that it is coming from the outer solar system. Typically, as I said, asteroids will come from our asteroid belt, but this was seen as an interplanetary, uh, interstellar kind of asteroid. It was lengthier, and because of its shape and all, people thought that it might be some alien ship or so, right? So that was one of the interesting thing. Again, I told that we study asteroids because they will tell about history of our solar system. We get to know how was the chemical composition and all at the time of our solar system, our Earth being Earth was getting birth basically, or how our solar system was forming. So we get original materials from that time. We also understand where life came on Earth. So I was telling extremophiles. Similarly, when you go to other asteroids, take samples, you can determine whether they have water content or other living organisms. And also, one of the main thing in today's era, what makes more sense is to explore resources. If they have something very exotic materials which can be utilized here on Earth, or it can be utilized when our astronauts are having interplanetary or interstellar missions, where you go there and refuel with some unique materials which might be available there. So instead of carrying all the fuel from here itself, you go and hop between different asteroids and planets. So that is one of the interesting way you can travel across the solar system, is just hop onto an asteroid which is relatively rocky and having a longer orbit. So when it comes to close to Earth, you just hop on that and just be there, right? Carry enough, instead of carrying fuel, just carry enough food and stuff. It will go and take you for like some 10 years of journey across the solar system for free, and bring back, and once it comes close to us, hop back to Earth, right? That is interesting. Yeah, so that is one of the reason why we study the asteroids. Of course, just for your understanding, asteroids also have comets, also have moons around it. So there is a Eris asteroid which is having one moon, and this particular Pluto is of course now a minor planet, but yeah, this particular asteroid is having two moons around it. So it is common to have moons around the other asteroids as well. Yeah. So far, we know several thousand. There are millions of them, but we track actively around 30,000 near-Earth asteroids. Okay, and we are interested in asteroids which are making kind of trajectories around the Earth's orbit. Of course, there are others also, but the ones which interest most of us are basically the ones which go close to Earth's orbit. Even if they're not going to hit in coming time, if they are having closer orbit to Earth, we will study them, right? Now, in today's era, it is one way is just go and destroy, another way is to divert. Okay. But the best thing which we can do now is predict their trajectories and calculate very efficiently where they're going to fall. As I told, big asteroids are not going to come and hit Earth and destroy complete Earth. That is very, very less probable. What is more probable is a medium size, a small size asteroid will come, it will explode in Earth's atmosphere and destroy that city. So can we predict which city it is going to hit or which part of the ocean it is going to hit, so that if at all it generates any kind of tsunamis, we can vacate the places around that, right? So there is a one predicted asteroid which is supposed to hit in Pacific Ocean. So people have plans of evacuating the seashore kind of habitation around that particular area. Similarly, we have to predict them. So what is the best thing we can do is calculate, do math, right? Very accurate math. But you can do very good math, but you need to observe them, right? Because you need to continuously observe these near Earth objects and see where they are going, if at all there is any change in their orbit over a period of time. And so for that, what you have to do is build larger and larger telescopes. And that's what I started with. I work on very important aspect of the asteroid observation is basically building telescopes, right? Once we build telescope, which can happen in next 5, 10, 20 years, we will have more information about where are these asteroids, right? So just a minute. So there is a recently, when I say recently, it is just a week back, a huge telescope is kind of released for observation. This is called as LSST, and it just observes the sky randomly. It doesn't do any specific observation, and it does this kind of observations. What you're seeing is over a few days, like first day, second day, third day. Now this might be like 10th day, and you see you started detecting these objects. Okay. See, this is the first night. It has detected 989 objects, then 1300 objects, 1600 fourth night, 1800 of them, 2000. And it is just a small piece of sky. There is a huge sky remaining still, right? And again, when we are observing, we are just observing outward because you can't see towards the sun using this telescope. So, but it is able to track all these objects within the asteroid belt and beyond. So such kind of telescope, this is a very large telescope. It observes big patch of sky continuously without tracking a specific object, but just observe. And what they do is they take images, like take an image today, tomorrow, day after. Once you have 2, 3 images, run it in a movie format. So if stars are there, they will remain at their original position. But if there is an asteroid, it will relatively move faster. And that is the one of the easiest technique by which you can detect the asteroids. And using similar technique or same technique rather, many Indian students have already kind of found out such asteroids by observing the differential images, right? So these are the examples. So school students can also participate in big campaigns where they give out images, several hundreds of images. You have to look on your computer, do this differential imaging. It is simple thing. It is basically observe first image, then next day, and then next day. You will see a blob moving. And if it gets confirmed, it is a new object, it becomes a discovery. Right. So many school students in India have already done similar observations. Yeah, I'll just skip that. Yeah. Also, there was recently, I think I skipped that thing, but recently we had one asteroid being named after Jayant Murthy. He is a scientist from Bangalore. He was a director of our institute as well. And one asteroid was named after him. So sometimes asteroids also get name of a person who have done very good contribution to the field, right? So, yeah, as I was telling, the big asteroids, we know 100% where are they. Mid-size asteroids, there is a probability if they come close, we know them. And there are so many meter-sized asteroids, we have no idea of where are they and how to find them. We get to know them only when they enter our Earth's atmosphere. So what is one of the implications of asteroid impact is you can go to Lunar, observe it, or go to MP, observe that other crater. But tonight, if you just go and observe Moon, and if you see those small dots like this, you might have seen Moon and its craters. all of these are made up of asteroids and meteoroid impacts over billions of years, right? So when an asteroid hits, it will create this kind of crater. Sometime, depending on the angle in which the asteroid has hit, you will see different types of craters. Okay, if it hits in the lateral direction, if an asteroid comes and hits in the sideway direction, this kind of crater will form. Where there will not be any peak in the middle. But you see here, when asteroid hits, it has created a peak in the middle. This is because it has done an impact in a tangential direction or like vertical direction. So depending on which direction it hits, you can see different shapes, and all these shapes, this along with so many other shapes, are can be seen on the moon. Okay, so if you observe moon next time, just don't see, but do observe. And what you have to observe is these craters. Okay. So today we have a small demonstration downstairs where you will be able to create your own craters. Okay. So by hitting the moon. So this is how you might have seen the moon. Now all these small dots are craters. So they will take you down in some time. But while going, you can just see, if you are interested, you can see this is a tektites and this is a meteoroid. Okay. You can see here and go. Okay. Have to go down and then towards your right, okay, while on the way. Interesting. Last week. Last week, yeah. So last week. We come here on this side also.
Harsha, pass here. Harsha, pass. Harsha, if I know it, they are going to judge the law. If I know. Harsha, yeah, I know. Oh, yeah. Little meteors. ये meteor का meteor chalk then on that meteor. I mean, the environment in oh no, these are other things. Yeah, we're just keeping them. I think